Hello and welcome to everybody on Cloud Fitness. So in today's video, we are going to talk about confusion metrics in machine learning. I'm going to show you what exactly is confusion metrics, why do we use it, right? Because this is very important, because as we try doing the hands-on, when we will do the hands-on, that time these particular terms will come and it is very important to understand what they are all about. So let's move ahead. But before moving ahead, I do recommend all of you to connect with me on LinkedIn as well as on Instagram, and I will leave the link in the description box. So when we talk about confusion metrics, right, this word itself will tell you that it is a metrics. Now what happens is, using this confusion metrics, it will help us to summarize the performance of a machine learning model. So let's say you have created a model, right? You have a set of test data, and you want to understand how is your model performing. Now to do that, you will use confusion metrics. But remember that this confusion metrics you will use in case of classification models, right? We have already discussed about all of this in my first video itself on machine learning, that especially for the classification models, for example, binary logistic, right? In that case, we are going to use confusion metrics where you can classify or label the output, right? You can categorize the output. In that case, you're going to use the confusion metrics. Now, if you look at the screen right now, you can actually see you have this is specifically taken as an example right now. So let's say you are trying to build a model which tries to tell you whether a particular email is a spam email or it's a non-spam email, right? So in that case, what we have done is the actual data, right, whether that particular email was a spam email, I have put it over here. Not spam, we have put it over here. But what are the predictions of your model, right? Your prediction basically means whatever your model has given as an output, right? Whether it has given you that particular email as a spam email or a not spam email, we have put it over here, right? Now if you look over here, in these 4 tabs, we have put something called as TP, FP, FN and TN. Now what are these? This is called as true positive, false negatives and true negative, right? Now the condition where this number of spam emails that were detected by your model were actually the spam emails as well, so that becomes a true positive. What does it mean? It means that the model has detected it correctly. It is a true positive. It was truly a spam email and it was truly detected spam by the model. Now in case of not spam, it becomes false negative, right? If you look at the actual output, right, that was a spam email, but your predicted model has told that okay, it's not a spam email, right? So it is basically a false negative. So your prediction is nothing but it is a false prediction. It's a false negative prediction, right? Similarly, let's say your actual is a not spam, right? The actual email is not a spam email, but still your model has called it as a spam email, although it was not a spam email, right? In that case, your predicted model, the prediction that your model has given, that is a false positive, right? Because it has given you a false positive indication, right, that it is a spam email, but it is not a spam email. In case the actual email itself is a spam email and the prediction is also that is given by your model, that is also a spam, in that case it is called as true negative, which means that both of them have correctly pointed out that okay, this is not a spam email, right? So this is what is called as your confusion metrics. Now even to give a little more detail, right, so let's say even to give a little more closure example, right, so let's say these are your actual values, right, 1 1 0 0 1 0 0 1, right, and this is your predicted value. So if you see for 1 1, it has predicted correct, it has predicted the correct values 1 and 1. For this particular value, the third row, right, the actual value is 0, but your model has predicted it as 1, right? Similarly, if you look over here, for the actual value of 0, your model has predicted 0. Now here the actual value is 1, but your model has predicted it as 0, right? Now when you create a confusion matrix for it, how it will happen, right? So if you see predicted values, right, what I'll do over here, just like what I've shown you over here, right, spam, not spam. So similarly, I can say that the predicted value is 1, predicted value is 0. Here the actual value is 1, actual value as 0. Now if you look at this particular data set, right, how many times it is a true positive, right? How many times it is a true positive? True positive means that both the actual and the predicted value is correct, right? It is a positive value. It is both of the values are positive values, both of them are 1, right? In this case you can actually see out of everything only 2 values, only 2 rows you can count where actual and the predicted values are are true positives, right? 1 1. So that is why we have mentioned it over here 2, right? Now similarly if you look over here, right, actual value is 0 and the predicted value is 0. So how many records are like this? If you see, this is the row where 0 and 0 is there, and here 0 and 0. So that is why we have kept it as 2 over here. Now similarly if you look at the predicted value is 0 but the actual value is 1, right? In that case you can actually see here the actual value is 1 but the predicted value is 0, right? Here also actual value is 1 but the predicted value is 0, right? So 2 records are like this. So that is why we have mentioned here 2. Now similarly the actual value is 0 but the predicted value is 1, right? So actual value is 0 but the predicted value is 1. So the third row, right? Now similarly the actual value is 0 but the predicted is 1. Now this is the second last row. So similarly you have got it 2 over here as well. So basically I hope you understood what is this concept of confusion matrix, right? So both the values are actually true positives because they are correctly they are correctly predicted, right? So spam email, it was a spam email, it was predicted as spam email by your model as well, and in actual also it was a spam email. So similarly if you see over here the actual value was 1 and the predicted value was also 1, so it is true positive, right? Now similarly if it was not a spam email and but your model has predicted it as a spam email, it is a false positive, right? Your prediction is a false prediction, it's a false positive prediction, right? Similarly you can see the actual value is actually 0 but it is predicted as 1. So how many records are there? Such 2, right? Now what are they? Those are called as false positive. Now similarly you have false negatives and true negative. So this is what your confusion matrix is all about. This will help us to evaluate the performance of a model. Now how it helps you to evaluate the performance of the model, that we are going to discuss in the next video. So I hope you like this video. If you did not understand it, I do recommend watching all my previous videos step by step so you understand each of these concepts, and try watching these videos 1 or 2 times so that it settles in your mind, and also write it with pen and paper so that it's very easy for you to understand as well. So I hope you like this particular video, and do remember to like, share and subscribe to my channel.